Hey, what's up everybody? I'm Tommy. Today, I'm gonna show you how I made this drill-powered benchtop lathe. Whether it's your first time here, or even if you've been here before, welcome to 1 Minute Workbench. I'm using Baltic birch plywood for this build because it's really high quality, really flat, and really stable. It's gonna make building the lathe that much easier. Basically, I'm just cutting up a bunch of strips that when arranged a certain way will form these channels. These channels will allow for adjustment of the headstock, the tailstock, and the toolbar. After I test to make sure these carriage bolts fit properly, I get started with assembling each of the sub-assemblies. To assemble the components, I'm using glue, pin nails, and screws. The cool thing about pin nails is they don't actually damage the wood at all. They're hardly noticeable, and they do a really good job of keeping the wood from slipping around. Using screws just makes it to where I don't have to use clamps and wait for each subassembly to dry before I move on to the next portion of the project. For every single screw I use on this project, I'm drilling a pilot hole and using a countersink bit. Here I'm attaching the first subassembly to the board that makes up the main base of the lathe. The way I designed this project is so that you only have to measure the strips when you're cutting them. After that, you don't actually have to measure anything to put it in the place where it belongs. All you're doing is lining up the edges of specific boards with specific other boards. As you can see here, there are two subassemblies that go around each side of this carriage bolt. To make each of the subassemblies, all I had to do was line up the edges. And in order to achieve the correct spacing in between the two subassemblies, I created this spacer that would fit into the channel. This spacer ensures I'll have consistent spacing for the next component. I wanted to polyurethane the inside of the channel, but I didn't want to put polyurethane where there might be glue, so I used masking tape to block the areas that were going to receive glue, and then polyurethaned every portion of the channel that I wouldn't be able to polyurethane later on after the two components were assembled. And here, I'm just testing the overall fit of all the components just to make sure before I keep moving forward. Once I'm pretty sure everything is fitting good, I continue on with the process of building the subassemblies and then adding them to the board that makes up the main base of the lathe. All the while being sure to use glue, pin nails, and screws. I'm also making sure to apply polyurethane to any places that are going to be difficult to apply polyurethane later on after the components are assembled. A lot of this process is pretty repetitive, so I'm going to move the video pretty quickly through this part. I think one of my cuts must have been slightly off, because when I added the last component, I noticed that it was hanging just over the edge of the baseboard of the lathe. And you can see that in this shot right here. This won't really affect performance though, so I just trimmed it on the table saw. After that, I moved on to building the headstock and the tailstock for the lathe. Just like the base for the lathe, these are simply rectangles that have been glued together. I made marks where I wanted to put my bearings, which is on each side of each of the upright blocks. I drilled a hole that was the depth of the bearing with a 7/8 inch bit. And though I don't show it on video, I also drilled through holes with a 5/8 inch bit. I then rounded the corners of the upright blocks. My bandsaw unfortunately was out of commission, so that led to some pretty creative and tedious ways to achieve the rounded corners. Before I attached the headstock and the tailstock to their respective bases, I decided to drill the hole in the base that would allow the carriage bolt to come through and lock either the headstock or the tailstock in position. I had originally intended on using triangular gussets to strengthen the headstock and the tailstock when attaching them to their base, but I decided against that because the screws I used were 1.5 inches long and they seemed pretty solid and pretty stable. Everything looked like it was fitting pretty good and looked like it was going to function well, so I moved on to creating the knobs that would lock the headstock, the tailstock, and the toolbar in position. I had originally intended on using these knobs as temporaries and then replacing them with star-shaped knobs after I repair my bandsaw. I actually like the feel and the function of these so much that I'm just going to leave these on the lathe permanently. Another really cool thing about these knobs is that they were just incredibly simple to make. They're just a couple pieces of plywood that have been glued together, and then I drill a hole through the center and then thread that hole. I'm using a 5/16 18 thread tap to tap the holes in these knobs, and that's to match the 5/16 18 carriage bolts that lock the headstock, tailstock, and toolbar in place. And then here I'm just easing the edges of the holes with a countersink bit by hand. I assembled the headstock and the tailstock into the base of the lathe to test it for fit and function. Everything was functioning really well, there was nice free movement, and the components were really strong and really stable. I was able to pick up the entire unit from the headstock and the tailstock, and it felt just rock solid. I did have a problem though. When I tightened the bolt, the square neck would wedge itself into the channel. And this made it to where when I loosened either the headstock or the tailstock, I had to push the bolt down in order to get it to move freely again. To fix that problem, I created these small blocks that are basically like a new head for each of the carriage bolts. I drilled a through hole, a space for the head to reside, and then threaded each one. I would put the bolt through, tighten it down in place using a hex nut and a washer, and what this does is it compresses the square neck of the bolt into the wooden block. After that, I would remove the hex bolt and the washer, and the pressure between the square neck and the wooden block would actually be enough to hold itself in place. The fit was a little bit snug at first, but after some sanding and some filing, it started to move freely. Making the toolbar was a pretty similar process to making the headstock and the tailstock. Basically, I laminated a couple pieces of wood and then cut the shape I wanted it to have out with a jigsaw. To make the base of the toolbar though was a little bit different. Instead of just drilling a hole, I needed a slot. To make the slot, I drilled a couple of holes and then drew lines to connect the slot. I had originally intended on using a jigsaw to cut these, but the hole diameter was so small I couldn't get my jigsaw blade into the hole. So I disassembled my coping saw, threaded it through the hole, and then used the coping saw to make this cut. To attach the toolbar to the base of the toolbar, it's the same thing I did with the headstock and the tailstock, where I used glue, pins, and really long screws. When it was time to attach the drill, I took several measurements to make sure the drill was going to line up perfectly with the bearing in the headstock. I then created this platform on which the drill would rest. To attach the drill to the platform, I just made a couple of slots in the platform and then threaded a large diameter hose clamp through the slots. And this hose clamp would then allow me to securely and easily attach the drill to the platform. I threaded a hole in this small block and then mounted the block directly in front of the drill's trigger. And this is going to allow me to control the speed of the drill. It looked like the speed control mechanism was going to work out, so I moved on to assembling the rest of the headstock. I got the basic idea for this functionality from a video by Izzy Swan. Thanks, Izzy. If you haven't seen that video, basically what you have going on here is a threaded rod that goes through two bearings. On either side, the threaded rod is locked in place by two hex nuts that have been jammed together. Then you have a T-nut that grips the workpiece to make sure it turns. At this point, it was time to test the lathe. Now, I had never actually used a lathe before. I didn't really know what I was doing, and I also didn't have a proper lathe chisel. So here, I'm just using a regular woodworking chisel, and you'll see at the end, when I'm done turning this piece, the results I get are really not very good. It might be the chisel, it might be my technique, or maybe a little bit of both. Another problem I was having was that the original spikes on the T-nut had actually broken off, and so it wasn't always turning the piece. Sometimes it would get hung up. So I created new spikes on the T-nut that were more robust than the original ones, and ever since I created these, it now grips the piece really well and turns it much better. Actually, after making that small adjustment, I started getting much better results. And you can actually see the better results on this dowel that I've turned here. It seemed like it was time to put the finishing touches on the lathe, so I disassembled it and started adding coats of polyurethane. In between every coat of polyurethane, I would sand and then use compressed air to remove the dust before adding the next layer of polyurethane. I made this little sanding block to help me get into the really tight spaces inside the rails for the headstock and the tailstock, and it came in handy for sanding other pieces of the base as well. Again, I put 5 or 6 coats of polyurethane on, and I used a lot of clear spray, but I also brushed on a couple coats of satin just to give it a nicer finish. After all that polyurethane and sanding, the pieces really developed a nice sliding action. I created this small switch box that basically just has a plug and a switch that controls that plug. This will act as a safety and allow me to cut power to the drill at any point in time. I then mounted the switch box to the lathe itself. There was one thing about the lathe that kept bothering me, and that was the amount of wobble in the headstock and tailstock. This is caused by the fact that a 7/8 inch hole is actually a sloppy fit for a skate bearing, and by the fact that a 5/16 18 rod is a sloppy fit for the center of the bearings. The 5/16 18 rod is too big, however, to put a bushing around, so I created my own bushings by coating the threads in epoxy. I also used epoxy to improve the fit of the bearings in the 7/8 inch holes. I used the drill and some sandpaper to grind the epoxy down to size for a perfect fit. At that point, the wobble was really down to an acceptable minimum. I reassembled all the components of the lathe and decided to give it its first real test. Most of the wobble was gone, and I had actually gotten my hands on some real lathe chisels. I was really happy with not only the performance of the lathe, but also the results I was getting from my workpiece. It was actually better than I had ever thought possible. I don't think I could be any happier with this lathe. It only cost me about $35 in materials, and I've already used it on an actual project with really great results. Hey, thanks for watching. I really hope you liked this video. If you haven't already, be sure to like and subscribe, and check out all my other cool videos. If you have any quick questions you want answered, hit me up on Facebook, Instagram, or Twitter. And until the next time I see you, I hope you have fun building something.